is a term that refers to how closely a measurement is to the corrected or the accepted value. So just looking at these two, what are these called? Things you throw darts at? Dartboard. There you go. This dartboard on the left, obviously we see all the dots are like right on that white, the inner white circle. That's probably the accurate circle to hit. So those dots are all accurate because they're all hitting the target, or they're close to the target. But the second dartboard that we look at, the dots are on the second ring, so they're inaccurate. They're not hitting the spot they're supposed to hit. So on the left we have accuracy, and on the right we have example of inaccuracy. In chemistry, you'll be measuring things, and you'll need to determine whether or not your measurements are accurate or whether they're inaccurate. If you're going to be determining whether your measurement is accurate, then you look at your single measurement and then you compare it to the accepted value. If it's near the accepted value, we say it's accurate. If it's far from the accepted value, we say it's inaccurate. Let's look at these 4 examples. An arrow hitting a bullseye. Well, that's obviously accurate. Correctly measuring water's boiling point to be 100 degrees Celsius. Well, we all know that water boils at 100 degrees Celsius, so if that's what you measure it at, then you do have an accurate value. A basketball player missing a hoop is obviously inaccurate, and if you measure water's boiling point to be 97 degrees Celsius, that's another example of inaccurate, or inaccuracy. Now, those are pretty simple, pretty basic, but what happens if you're doing multiple measurements? If you're measuring multiple things inside your laboratory and you want to see whether or not you are getting accurate results? Well, if you have multiple measurements, you first need to average them together to get one result, one averaged result, and then you can compare that averaged result with the correct value. Number 1 says when your average percentage of making a three-pointer is 90%. That's an example of accuracy. Does that mean you made the three-pointer every single time? No, in fact, since it's 90%, you probably missed it sometimes, right? But since we're referring to the average of all your tries, we can say that your average was accurate. Number 2 says when you average your 3 test grades of a 70, 100, and 100, and they average together to be a 90. The average itself is accurate, so we would say these are accurate results. Now, even though you got that 170 and the 70 itself was inaccurate, since it averaged together to be a 90, we call those results accurate. Number 3 says when your average percentage of making a three-pointer is 50%. That is an inaccurate average. Number 4 says when your average of the 3 test grades of 70, 75, and 90, when those average them together, they become a 78, we would say that's an example of inaccurate multiple measurements. Okay, so that's accuracy. Now I want to talk about another term that you're probably a little bit less familiar with. It's called precision. And precision is a term that can really mean 2 things. Precision can refer to data, and precision can refer to measuring. Okay, so let's first talk about what does precision mean in reference to data. Well, precision can refer to how closely a group of measurements are to each other, and also, which is also known as the range of numbers. So let's look at the 2 dartboards again. Oh, it's a bullseye. That's what it's called. Let's look at the left bullseye. The dots, even though they're accurate, they're in the middle, are they all closely arranged together? They're not. They're all separate. So we say that the person who was throwing whatever at the bullseye was not precise. Now, the guy who did the darts on the right, even though they weren't accurate, they're not in the accepted value spot, they are all close together. So we say that his data there is very precise because he's hitting the same point over and over and over again. Now, how does that refer to data? Well, if we're looking at numbers, let's look at the first example. All the arrows hit around the same spot on the bullseye. That would be an example of precision, okay, or precise data. Notice the spot does not have to be on the bullseye. Just because it's precise data doesn't mean that the data is actually accurate. It just means the data is very close to the same value all together, okay? Number 2, when you measure the mass of an object 3 times, okay, and the first time it comes out to be 10.9 grams. The second time it comes out to be 11.0 grams. And the third time it comes out to be 10.8 grams. What's our range of the data? Well, the highest number was 11. The lowest number was 10.8. So our range is 0.2 grams. That's really precise. That means every time he measured this object, his measurement only fluctuated 0.2 grams. So really close data. They're all very near the same value. Let's look at number 3. Let's say you get 3 test grades back. One's a 70, and then the other 2 are hundreds. Even though for them, when we average them together, the average is 90. That's accurate. Okay, so you're showing accuracy in your results, but you're not showing precision in your results. So this would be an example. Number 3 would be an example of imprecise data. Let's say you're measuring the melting point of a substance, and first time you measure it's 75 degrees Celsius, second time it's 85 degrees Celsius, and the third time it's 80 degrees Celsius. Well, what's your range of data? Well, the highest number is 85, and your lowest number is 75. So you have a 10 degrees Celsius difference, and that's a lot when you're talking about melting points or temperatures. So this would be another example of imprecise data. The second way we can refer to precision is when we're talking about measuring things. Okay, precision can also refer to how closely a certain piece of equipment measures another object. So number 1 says a graduating cylinder measures in 1 milliliter increments. Increments are those little lines inside when you're measuring the lines that you actually read. Those are increments. And so if they're in 1 milliliter increments, that means they're really small. They're really close together. So we are measuring very, very closely. Number 2 shows a 600 milliliter beaker. Okay, so it's a larger beaker. But the increments are in 100 milliliters. That's very imprecise. It doesn't tell me very closely the number that I'm measuring. It only tells me in 100 milliliter increments. 3 measures in 0.001 gram increments. That's very, very precise, very close, very specific. And number 4 measures in 0.1 gram increments. So that's not very close. That's not very specific. So we would say 3 is precise and 4 is imprecise. Let's look at some sample data. We had 4 different students. They're by the 4 different thermometers. And each thermometer measured this liquid's boiling point 4 different times. Oh, by the way, this is water. We're measuring the boiling point of water. Well, the boiling point of water is 100.0 degrees Celsius. So thermometer number 1 on the 3rd trial measured it the most accurately. Which thermometer is the most accurate in the table below? Well, if we're looking at 1 thermometer, how many measurements did they do? They did 4. So we would have to average those measurements to see the average of each thermometer and then figure out which thermometer was the most accurate. Well, the average has already been calculated for you, and if you look down at the table, thermometer number 1 has the closest average, the most accurate average. So thermometer number 1 would be our most accurate. Which thermometer is the least accurate? Well, if we look at thermometer number 4, they measured water's boiling point to be 97.0. That's 3 degrees Celsius off from the accurate value. So we would say that's very inaccurate. Now let's look at precision with measuring things. Which instrument below would you want to measure 500 milliliters of water in? Well, the first question is we need to find which beaker can we actually put 500 milliliters of water in. Well, the only one that we can put 500 milliliters of water in is number 1. So we would have to use beaker number 1. The second one asks which instrument would we want to measure 15 milliliters of water in. Again, we ask ourselves, well, which of these containers can hold 15 milliliters? All of them can is the answer. So now our next question is, which instrument would give us the most precise data? That would be number 5. If you look at number 5, the big lines are in 5 milliliter increments, and then the small lines are in 0.5 milliliter increments. So that's very, very specific. So we would use graduating cylinder number 5. The last one says, which one would we want to measure 250 milliliters of water in? Again, we have to ask ourselves, which of these containers can hold 250 milliliters of water? Well, you might be drawn to think number 3 could, but if you look at the lines only say 50, 100, 150, and 200. So we really don't even have a line for 250, so we couldn't use beaker number 3. We would have to use beaker number 1. Okay, I want you to stop the video right now, have a time, answer your big picture questions, and then start the video again. How is percent error calculated, and what is the importance of calculating percent error? Percent error is a way that you can measure how accurate or inaccurate you were in your results by using percentage. So I have my handy dandy board right here. So I'm going to show you how to calculate percent error. Pretend that this experiment was measuring the boiling point not of water, but of something else that measures 97.5 degrees Celsius. Okay, so the actual is 97.5. Thermometer number 3 measured their average to be 98.5, so that's the experimental value. Okay, so we do 98.5. 97.5 minus 98.5 divided by 97.5 times 100. Now, when you're putting this in your calculator, do not put the times 100 in yet. Just put this into your calculator. Alright, so when you get this answer, you should get negative 1.03, and I just rounded up. So, what this negative tells us is that we were under the value. My percent error is I was off by 1%. That's my error. Okay? So let's do some more calculations with this. What would be the percent error of the student using thermometer number 2? Well, we use the same data. We're just going to change the experimental. Got 100.1. So we'd put 97.5 down here still. When you plug this into the calculator, you get negative 2.67%. Okay. What this means is that they are off by negative 2.67%. The last question is, what would be the percent error of the student doing thermometer number 4? Go ahead and pause the video and calculate it on your own, and then start it and check your answer. Okay, so I would still be using my same actual temperature, but my experimented, when I put that into the calculator, I get 0.51%. Okay, next I'm just going to have you do the tying it all together on your own. So I'm going to get back to hammering some stuff, you know, like pictures and nails and things. But have a great day!